Okay, so here we are. For many of you, this will probably be the last course that you have to take for the apprenticeship program. Hooray! Okay, and so good luck on this course. The course is digital electronics. Okay, and digital electronics is totally different than analog electronics. Up until this moment, you've learned all about analog circuits, DC circuits, AC circuits, three-phase circuits, all devices that run on AC, DC, and three-phase AC, and so forth, sensors that run on DC and AC, um, semiconductor devices that require DC in some cases, but they can also operate on AC as well. So you've learned all of that, and that's all analog circuitry. And analog circuitry is really the power of an entire electronic system. It does all the work for you. Okay, it does all the work for you. But if you have a specific process to perform by your analog circuit, okay, you need to make sure that there are some controls so the process, the individual items in the process, the steps are done smoothly and without fault. Okay, and that's where the digital circuits come in. The digital circuits actually create a set of commandments that control the on and off of different elements of your analog circuitry and also display the results to a display device. So digital circuits take information from the analog system, okay? They digitize it first and then they process it, calculate some things, set examples for, or test examples for, is this running properly, and so forth. And then um, turns on or turns off specific items in your analog circuit. So that's the function of digital circuits. The digital circuit is a digital circuit because it runs on a binary system. Binary meaning, in this case, being two digits, the 0 and the 1. Okay, that's easily programmable. Or you can think of 0 and 1 instead of being 0 and 1 can be a on or off. It's a switching. So a digital circuit, for the most part, is a switching circuit. Okay, what switches on, what switches off, and also calculates when this should happen. So it is a timing circuit. Timing is extremely important to digital circuits. So the last course we figured out, we've seen how we can create clocks, oscillators. Oscillators are clocks, clock signals. Okay, we use clock signals in digital circuits to make sure that the timing is exact. Okay, that we don't miss a beat. That we don't. If we have a digital array of numbers, okay, we want to make sure that they are in the proper sequence and that they have the right significance. If just one bit is wrong, the whole thing goes kapoof, and the whole system has to restart over again and start from the beginning and do it all over again. Okay, that's the beauty of a digital system. It helps to make things run smoothly, and if it also detects where things are not running smoothly and whether it should restart. So the importance of digital circuits is timing, and the ability to communicate. Okay, the ability to communicate by uh, giving you real life numbers or status symbols for the position of any particular item. Is everything going well? And so forth. Okay, is it a red flag or is it a green flag or is it a red flag? That kind of stuff gives you all that information. Digital systems does that. So we're going to start with um, today with understanding what a digital device is. Okay, it's more than just numbers. Okay, it is a system of logic, and we will talk about logic later on this week and into next week. So for now, we will just go over the idea of what is a digital system. Digital system is a system that regulates and an analog system. Okay, so if you have any questions, again, bring them up. And if you can, if you do the self-test questions, send me the ones that you can't answer or have a tough time answering, and I will answer them, give you my answers for them. So make it a practice to do that on a daily basis, do the self-tests, and then do the in the book. And if you have questions that you can't answer, then send them to me, and I will send you all the answers to those hard questions. All right, so let's get going.